All right, so this is the a kind of a mini lecture on correlation analysis. We'll be looking at the steps, the properties, the assumption, what really correlation analysis is all about, the things you need to know, decision rule, the degree, and of course the step-by-step means of conducting regression correlation analysis in Eviews. And of course we're going to do some practical steps using Eviews and the data set provided. So what really is correlation analysis? And so we want to know what correlation analysis is. So correlation analysis, um, this has to do with the statistical method that is used to evaluate the strength of two quantitative variables, just like we are looking at the variable gross domestic product and government expenditure. So we're looking at the strength in association or relationship between these two variables quantitatively. Now, the instrument or the test or the coefficient used is the Ferson's correlation coefficient. Now, Ferson's correlation coefficient is a test that measures the statistical relationship or the association between two continuous variables. Of course, Ferson's, we call him McPherson's. He is the developer of this correlation um, coefficient used to see how to measure the strength or magnitude between two quantitative variables to exercise the strength. Now, to exercise the strength, and it gives more information about the magnitude and the direction of the relationship. Direction in the sense that telling us, is it positive, is it negative, is it highly positive, is it perfect, is it not perfect, is there no correlation? So we'll see this as we proceed. Now, what are the assumptions of correlation analysis? Now, there are three basic assumptions of correlation analysis. Number one is independence of cases. The cases should be independent to each other. Two, linear relation. Of course, it has to do with two variables. That simply means they have to be linear related to each other. This can be assessed with the scattered plot. Of course, when we go to Eview, we'll be able to conduct tests on correlation and also know how to conduct a scatter diagram to exercise this linear relationship. Now, homoscedasticity, that simply means the residual in the scatter plot must be roughly rectangular in shape. Of course, we are going to see that also. Now, let's go to the properties. Now, properties simply means what are the basic the basic ingredients or characteristics that must be involved to see that this is a correlation coefficient. Now, number one, limit. Coefficient values range from +1 to -1. So once it enters 2, that simply means it is no longer a correlation. And so it's either it is negative or it's either it is positive. Or we have 0, that indicates no relationship at all. Now 2, pure number. That simply means there must be a unit of measurement. That simply means you must not use one variable measurement and use a different measurement for another variable. So if I'm using the metric tool for GDP as in billions, that simply means for government expenditure I should also use in billions. Now symmetric. Now the correlation of the coefficient is between two variables that are symmetric. That simply means x and y. That simply means the x is the horizontal, the y is the vertical. So the relationship between the x and y and the movement must be the same. Now let's look at the degree. This is very, very important. This is very, very important because this is where most researchers don't understand how to go about to interpret correlation analysis. But I tell you, if you can understand this, you can be able to interpret correlation analysis or correlation variables between two variables. Now, what are the degree of relationship of correlation? Sorry. Now, number one, perfect. Now, if the value is near, that is +1, or near to 1, then it's said to be perfect correlation. That simply means as one variable increases, the other variable tends to do what? To also increase. So as GDP increases, as GDP increases by +1, that simply means government expenditure will also increase by +1. That is what we mean by perfectly correlation. And high degree, if the coefficient value lies between 0.5, that simply means it has a strong correlation. But moderate degree, that is 3, if the value lies between 0.30 and 0.49, then it's said to be medium, or moderate degree. Then low degree, when the value lies between 0.29, then it's said to be small correlation. Then no correlation is when the value is 0. So once you have 0, 0 as a number, that simply means that there is no correlation. And remember, we can only have two types of correlation. It's either it is negative, three types of correlation. Is either it is negatively correlated, it's either it is positively correlated, or it's either there is no correlation. Now let's go to the steps. Now these steps will guide us in conducting the correlation test in our Eview. That should be the next thing we'll be moving on now. Now, step to step procedure in conducting correlation analysis test. Now, of course, we import the data, highlight the data, open as group. So these are the steps. Of course, you should be able to read this. So we are going to go into Eviews now. So next is that let's go to Eviews. Now this is Eviews, and we already have these tests already outlined here, where PIB is GDP, and ECG is government expenditure, and we're looking at the quarterly data from 2000 first quarter to 2019 second quarter of the fourth quarter, with 80 observations. So we want to conduct the correlation analysis for this. Now the first method is that we have imported our data from Excel, and having done that, we go to view, view in the left corner. This is view. Sorry, first of all, we are going to highlight this. So let me highlight my data. So I highlight GDP. I also highlight government expenditure, and I'll click as open as group. So in one window, okay, I'm opening as group. Good. So this is group now. So government expenditure, and this is GDP. Now what next? I'll go to view. This is view, and I'll go to covariance analysis. I'll click on my covariance analysis, and this is a dialog box. The dialog box is over here. So I will unlight this. I'll unselect covariance, and I'll select a correlation, and I'll also select probability. I want to look at the correlation, and I want to also look at the probability of the test, and I'll select OK. Now this is my correlation test. So this is my correlation test. You can see it's telling me correlation and probability. So my correlation test for GDP. So you can see here that from this test that GDP has GDP, of course, has a positive correlation with government expenditure at 0.3, and the probability is 0.03. That simply means it is statistically